Hello and welcome to another session of NextGen 24. My name is Ajinkya and I'm excited to welcome all of you. Today's session is Enhancing Traffic Oversight with Autonomous Drones and AI Analytics. This session will delve into the transformative potential of drones coupled with AI to redefine the landscape of traffic control, ensuring safer, more efficient navigation across both bustling cities and secluded areas. With that, I would like to introduce our speaker, Petr Dvorak from DataFromSky. Petr is head of aerial intelligence at DataFromSky, being responsible for aerial applications of the TFS workflow. Petr served as a management committee member for EU COST, acting as a CEE tech rep for Dinan Avionics USA. He gained a detailed insight into avionics for manned aircraft as well. He has been responsible for development of image correlation optical measurement systems at Sobriety and is therefore in a great position for optical payload integration into UAVs. Having earned his degree in aerospace engineering, Petr has more than 25 years of experience with unmanned aircraft. Before we get to the session, I would like to share a few housekeeping rules. Please feel free to type in any questions you might have during the session in the Q&A chat box. The session is getting recorded and will be published soon. We also have the booth in the expo section. Please make sure you visit it during networking and booth visit slots. Last but not the least, please remember to capture your favorite moments of the session and share them on Twitter and LinkedIn by using #NextGen. I would also like to thank our sponsors, title sponsor DJI Enterprise and gold sponsor Sunflower Labs. With that, over to you, Petr.
Thanks a lot, Ajinkya. I hope that you are able to see my screen. So let me just switch to the presentation. It's a great pleasure to be here. Thanks a lot for all you to come to our session. And let me just start. Basically, how we started. This is something that happened in 2014, and we started as a spin-off from a university project where high number of counts and very high precision for traffic survey was needed. So that's how we established ourselves, and we are basically the first ones to offer traffic surveys from a drone. So we basically defined this market 10 years ago. Since then, this technology has proven to be very useful for a number of purposes. So we have created a lot of use cases, and some of them proved to be very, I would say, big enough so that they managed to get their own brand name, such as parking detection, where we are monitoring and looking into more than 30,000 parking lots every second all around the globe. Over the years, we have been able to work with brilliant customers, and we have been performing very interesting projects for them. So this is an example of a major project that has taken place in Athens, in Greece. We have cooperated with EPFL, Lausanne, Switzerland, on this project, and it's been 10 drones flying simultaneously for several days, creating the biggest uninterrupted digital twin of traffic, urban traffic in the entire neighborhood in Athens. More than 100 intersections have been covered. This is actually an open research data set, so if you are interested, we can give you access to this. It's called Pneuma. It's publicly available for researchers. Right, so what we are actually talking about, this is a random video feed from a drone with the detection of the objects of interest enabled. I mean, nowadays it's nothing special, although it used to be very special in the days when we started. But this is just the first step, right? You take the video feed, and then you basically divide it into every frame, and in each and every frame, the artificial intelligence or the deep neural network that we trained and use basically says this is a dog, this is a car, and this is a truck. So that's what we do for each and every frame in the video. But it's also only the first step for us to be able to connect the movement of the vehicles or objects into meaningful trajectories. We need to then connect these individual detections together, and in order to filter out noise and some movements that wouldn't be feasible in the real world, we deploy a long developed in-house algorithms that are assuring or are taking care of producing very smooth and connect trajectories. So this is a very crucial step, because if you just connect the different detections without thinking about how you connect them, then you might not be able to do the third and I would say most important step. Why we are all talking about this is that we need to interpret the data and get meaningful and actionable insights from them. That means that, for example, we want to see how many yellow cars are turning from the west to the south. And if we had the trajectories not connects, that means that we would have one detection here, but the algorithm or the computer wouldn't know that it's the same object during the whole time. We wouldn't be able to filter the vehicles or the objects of interest, and basically the data would be much less useful than they are when we deploy all the steps that we have developed in-house over the years. Right, so these are basically the results, or what you can do with the data once everything has been processed correctly. So as you can see, you've got counts at different gates or virtual induction loops, as you can name them. You can have velocities, accelerations. Obviously, we are categorizing the objects into, nowadays it's something like 15 categories, and you are able to produce heat maps of velocity, acceleration, and stuff like that. So it's very rich data that serves for example, redesigning the traffic point at this for this very example, but you can do a lot of things with this richness of the data. What's more, since a few years back, we are able to do all these steps in real time. That means that you are able to deploy the drone, near a highway or your scene of interest, and you are able to get obviously the counts, but also the gap times in real time, the velocities, and you can also analyze the behavior of the vehicles for some unwanted behavior. So basically, you can use it for law enforcement in real time. And that's actually what I wanted to show you right now. This is what Central Bohemian police officers are doing. And it's the world's first application in this context, because they are using our technology to detect and measure gap times between vehicles. And they approach the drivers right at the spot where they trespass regulations. Okay, so hopefully you've been able to see the video. So as you have seen, the deployment scenario is pretty straightforward. In this case, we've got a unit that's called traffic drone unit. It's basically a very powerful field computer that sits, at the deployment site. Basically, the officers come near to the highway, fly their drone. They stream the video to the ground station, and directly from there they send it via HDMI cable to our unit, and they receive the insights on the spot in real time. So they are able to directly approach the drivers there. Obviously, the scenario is very flexible in terms that you don't have to carry the computational power to the deployment site. You can stream the video via internet to your centralized control room and do the processing over there. And in the very same manner, I think it's very relevant to today's conference, you can deploy your solutions where the drones are being deployed automatically from all around the world on multiple sites and do the processing in centralized manner. Obviously, you are able to connect from all over the world to the insights or to the analyzed results. So that's actually what we are doing to present right now. So let me just switch to our environment. And this is what we've got, or this is the traffic insights or flow insights, an environment that we provide to the customers where they can access, the extracted insights from the traffic stream. So obviously you can have more scenes or environments predefined. So that means that if the drone is leaving the dock for a certain location, you just enter a predefined scenario, and you don't have to configure it all over again from the scratch. So this is actually a pre-recorded stream from Lyon in France, where we have done a joint demo with our tethering supplier, Alistair. And I would like to demonstrate, the basic functionality of the flow framework on this. So as you can see, once you feed the video stream into the system, you get all the targets annotated and classified. But we want to have some measurements as well, apart from only the visual outcome. So this would be the exit gate. I'm just drawing some virtual gates over here so that we can then work with them and don't get lost in the data. So just like this, I drag and drop these filters. Basically, they are spatial filters, and we are by these we are filtering out only the trajectories that have passed through these gates, and I've got the counts that fulfill the criteria over here. So you can see that in the direction of Lyon, we have had this number of vehicles passed since the beginning of the analysis. Okay, so that's the very basic stuff. Let me just add some widgets so that we've got a better overview of the situation on the dashboard. And I'm also interested in the distribution of the vehicles, in the type of vehicles that are driving in each of these three directions. So this is what we have done. We can see the distribution of vehicles for all of the three gates. And I can see the counts as well. We can visualize it in quite a neat way. So let me just copy the main outbound gate over here, and just by dropping the exit value on it, I'm creating this so-called super widget, and obviously, let me just color it. So the green ones will be those that are staying on the highway, and the red ones are the vehicles, the proportion of the vehicles that's departing from the highway. So very basic stuff. Obviously, I can. Sorry for this. I can add a real-time overview of the situation. It's already been here, so let me just drag and drop it here. So in this way, we can build a dashboard for a quick overview of the situation. Now, in France, as you might know, it's a big theme there is tailgating, or driving very close to the preceding vehicle. It's actually one of the most dangerous offenses, traffic offenses, because when the vehicle before you starts to brake, then the vehicle after don't have enough time to react, and it leads to a lot of fatal crashes. So let me just create a gate where we are going to measure the gap. It's called gap, and we are going to calculate gap at this gate, and we are going also to collect evidence. Okay, so now we have filtered the vehicles that are driving through this gap gate, and we are going to filter down only the vehicles that have had the gap time lower than 2 seconds. That's the safe threshold. And all of these vehicles that are driving dangerously are going to be output into a table. So in my dashboard, I've got a table with all of the vehicles, obviously their speeds, accelerations, and the gap times. And all of these gap times are lower than 2 seconds, because these are only the vehicles that I filtered down, the vehicles that have been driving dangerously. To take it further, I can define an evidence event or task. So this would be gap evidence. And source of my events would be the table I've just shown you. And let me just add an image evidence. That's the gate that we have defined earlier. And I'll add that one once again with zoomed in view like this. And for this view, we don't need any enhancement of the image. So yeah, my limit is 2 seconds, and then we are on the highway, so it's 130 kilometers per hour. I'll save the evidence task, and in my storage, I immediately get evidence protocols generated for each and every of the vehicles that we have seen in the table, right? So let me just download one of those and show them to you so that you can see how these evidence protocols look like. Actually, this is the official Czech or Central Bohemian Police Department protocol. So sorry for it being in Czech, but basically you've got all the vital telemetry data here, and you also have the image evidence present here together with zoomed in view. Okay, so this has been a very quick demonstration of the flow. It's a really powerful platform, so if you are interested, just don't hesitate to contact us, and there's a lot that you can do with this. Okay, so let me just continue with the presentation. Just a quick overview of the applications that you can use the technology for. So obviously the standard one would be traffic surveys for the purposes of redesign of your traffic network and so on. And it's been used very widely by our partner COVI in Scandinavia for improving safety around schools, and obviously improving the infrastructure for active mobility, cycling paths, and so on. It's also an ideal tool for feeding the behavioral data into your simulation models, such as PTV and stuff like that. Obviously, you can use it for security purposes and crowd management, or for your retail and analysis of behavior of the customers, where they are delving more, spending time in front of which shop and stuff like that. Yeah, contrary to popular belief, the technology is very robust, I would say, in terms of weather and conditions. So the rule of thumb is that as long as a human can see the objects, then the neural network can recognize and see and recognize them as well. That means that we are able to work even during the night, fog, rain, and so on. And if that's not possible, we do employ a special detection of such a condition. So if you've got a fixed camera installed at the roadside, the system basically sends you a notification that the conditions aren't fulfilled for a meaningful analysis, and it also stops the analysis. Okay, so with that, I think it's the end of the presentation. Thanks a lot for your presence, and I'm open to any questions if there are any.
Yep. Thanks a lot, Peter. Thanks for that live demo as well, and sharing those different use cases, how the solution is being used in different countries. So that's really insightful. And thanks for highlighting those data points. So we have a lot of questions coming in. So I'll just go through the questions one by one. So first question that we have is, the audience is asking, is DFS a web-based application?
Sorry, what was that?
Yeah, is DataFromSky Flow a web-based application?
Well, we've got multiple scenarios. So for the post-recording, that means that where you basically record the situation with your drone, you are able to upload then the recording to our website, and we process it for you, and you just download the results and you are able to interpret them, and it's very computational resources light, so you can do it on your computer. But obviously for the real-time stuff, you basically need to have a dedicated machine for that. So we either offer these machines, or we are able to, or you can work with your own computational hardware that's up to the specifications that we provide you, and we just supply the software, and it's on-premise deployment then. So it's really very versatile.
Thanks. That clarifies the answer. And another question we have is, can a drone be deployed when an alarm is triggered and upon reaching it, it detects the vehicle and send a notification? So let's say there's a third-party application that gives data that some vehicle is speeding, and then the drone goes to that location. And then just to verify the data from Sky or the Flow platform can then be used.
Sure. I mean, as I've shown, we've got these. Basically, we've got a wide variety of ways how to interact with the outer world. That means we've got API, both REST and UDP API. We are able to send webhooks. We are able to directly control, for example, traffic lights or traffic controllers. And we are also able to directly control input-output relays. So that means that you can light a warning light or open and close the gate and stuff like that. And all I've shown you the basic way how to generate the evidence, but these evidence events are also being sent via webhooks, for example. So again, it's very easy to integrate all the data and the insights that we generate.
Right. Thanks again. So there are a lot of comments appreciating the accuracy of data, detection of the vehicles. So on those lines, one question is, does the platform also, is it also able to detect pedestrians or human walking?
Sure. Yeah. Pedestrians are one of the basic categories. As I've said, we've got more than 15 of them now. So you can have not only pedestrians, but prams and e-scooters and stuff like that. So we even have like a finer resolution within the general pedestrian category, but that's more applicable to fixed camera views where you've got your camera looking or installed at the roadside, and you've got I would say a detailed view of the targets, because from the drone it might be difficult to see whether that's a standard pedestrian, I would say, or a pedestrian riding a e-scooter. So there we restrain only to the pedestrian category. But even from a drones, the detection of pedestrians is very robust, given that the detection resolution is high enough. That means that basically we need to see the target or the pedestrian in order to be able to recognize it.
Great. So yes, we are out of time, but you can again reach out to Petr via the website or directly from DFS DataFromSky social media, as well as we also have networking booth where if you have any specific questions, you can talk to Petr. And so thanks a lot, Petr, for that wonderful session about how you can enhance traffic oversight using AI analytics. So really thank you for joining us today, and really appreciate your time today.
Yeah, thanks a lot. It's been a very nice event, and thanks for having us. It's been a pleasure.
Perfect. Thank you, everyone. And just one quick note. So we have started an exclusive invite-only community for all the drone autonomy enthusiasts. So my colleague, our team will share the link with you. It's also available on the reception. So feel free to register to it. Thank you, everyone. Have a good day. Bye.
Bye.